This is the Malkani bike computer. It is comprised of a custom PCB that revolves around the Atmega 328P MCU and is capable of in-circuit system programming. The PCB fits nicely into its custom 3D printed case, which also has a custom 3D printed handlebar mount for indoor biking. The Malkani bike computer was designed to have two sensor inputs, one for the rear wheel RPM that tracks each rotation of the rear wheel, and one for the pedal RPM that tracks each rotation of the pedals. These two measurements can be used to calculate speed and cadence, two of the most important metrics in indoor bike training. So let's see it in action. First, MBC is switched on. Then, the timer is started, and the user can start pedaling. Now speed, cadence, and distance are all being tracked and projected on the LCD display, which is using the liquid crystal library. When done, the user can choose to pause or reset the timer or stopwatch. In this case, we'll pause. The sensors in question here are magnetic reed switches. 5 volts are set into one end from the computer, and when a magnet is near, the circuit is closed, sending a positive signal to a digital reading pin on the MCU. Once the computer finds out there's been a 5-volt signal to its digital reading pin, it triggers this if statement, which essentially boils down to this one in simple terms. If the pin is reading 5-volt signal, and if it has not been 20 milliseconds since the last input, which is the debounce check, then it'll set the RPM to 60 seconds divided by the time since the last 5-volt signal. That brief calculation gives us an RPM value for that sensor. This if statement occurs on 2 occasions, first one for the cadence sensor and a second time for the speed sensor. 2 RPM values are then calculated, and one of them is displayed on the LCD screen as the cadence value, and the other one is taken on for further speed calculations. The speed calculations are relatively simple. All it is the RPM value is multiplied by the circumference of the wheel, which is 2.136 meters. That is multiplied by 60, as in 60 minutes, and then that is divided by 1,000, so it goes from meters per hour to kilometers per hour. To get a better look at how the sensors are connected and work, this is a magnetic reed switch connected to 2 male DuPont wires, which are then connected to the sensor dongle from the Malkani bike computer. This is a magnetic probe in a 3D printed case, and you can see it trigger the RPM value on the screen. Here's the same demonstration using the speed sensor. It's the exact same sensor, just plugged into the different input. This time it also adds up the meters on the meter count. After 1,000 meters, it also converts to kilometers, as seen here. Here's a quick explanation on the design. The screen is on a folding hinge, and on the back there's a 5-volt power jack and an on-off switch that controls the entire computer. The screen flips back up, and the sensor dongles can be seen on the side here. On the bottom is a honeycomb designed to save weight and material while printing. The sensors are mounted to the bike using 2 custom 3D printed and designed mounts that are also zip tied to the frame. The speed sensor mount is mounted near the rear hub, the cadence sensor mount is mounted near the pedals, and all the wires coil up top to find a custom 3D printed handlebar mount that is secured with 2 M3 screws and holds the computer nicely. Thank you for watching, and I really hope you enjoyed this video. This project was completed for my long independent study project in the RSGC ACES program, and to create a cost-effective bypass to the crazy expenses of indoor aerobic-based training on a bike. Aside from a watt reading, this project produces nearly all the same metrics as flagship indoor bike training setups at only 16 Canadian dollars, plus the cost of a cheap rear wheel resistance trainer. That adds up to less than 40% of the next cheapest name brand option. If you would like to recreate this project, I've linked the GitHub repository with all the code, 3D files, and links needed to do so in the description below. Thank you and have a great day.